Hello, welcome back. In example number 2, we're asked to find the absolute minimum and maximum for our function f of x, y is 2x squared minus y squared plus 6y. But this time we're being bounded by a disk on the xy plane of radius 4. So what we want to kind of imagine, if we imagine like in our 3D plane here, we have the xy axis, and we have a disk of radius 4 going around like so. And above that disk, we can imagine our function. There's our f of x, y right here. And what's happening is we're going to project this disk. Remember, in 3 dimensions, this disk creates a cylinder. And what we want to find is on the cylinder that's being projected up to our functions, we want to find the absolute maximum and the absolute minimum values. And of course, and that's what we're trying to find here. As we talked in our last video, to find the absolute maximum minimums, this is going to use our candidates test from Cal 1 and Cal 2 last year. So the first step we have to do is we have to find those critical numbers and the critical points. Well, to get the critical numbers, we need to set our partials equal to 0. So the partial with respect to x becomes just 4x, and the partial with respect to y becomes this negative 2y plus 6. And again, I get that from my function right up here. We want to find, to get the critical numbers, we want to find out where both of those are equal to 0. So if we set the partial with respect to x equals 0, we get x is 0, and take the partial with respect to y equal to 0, we're going to get, of course, here, y equals 3. So one of our possibility is going to occur at the point 0, 3, blank. We got to find that z value there. We'll do that later on. Next, after we get the critical numbers, remember from our previous video, once you get and up here, we have to look at the edges themselves. Going around, we have to look at that edge. That's that intersection of the surface and our bounds of our circle. So next, we're going to, like I said, we're going to take a look at the edges. And again, the edges is the trace, that intersection of the circle, our bound, whoops, sorry, can't spell circle right, of that circle with the function. And to do that, looking at the equation of our circle, we want to find out where our circle, which is this x squared plus y squared equals 16, we want to find out where the circle intersects the function f of x, y. We just want to find that intersection. So if we're here, I'm going to go ahead and solve for either x squared or y squared. It doesn't matter. I'm going to go ahead and solve for x squared. That's going to give me 16 minus y squared. And I plug that in. I will get f of x squared y equals. Now notice, I didn't solve for x because if you look up here, x is already being squared. So I'm just going to plug in my x squared. Makes it a little bit easier for me. And this becomes then 2 times 16 minus y squared minus y squared plus 6y. And if I simplify this, we're going to get 32 minus, that becomes minus 2, minus 3, so minus 3y squared plus 6y. Now recall, this is a trace, this is the trace of our circle, of our cylinder on that surface. So remember, we're looking at a trace here on the surface. And we want to find out where this trace has a relative max or min. And that's what we're going to find here. So to do that, we're going to take the derivative of it. Taking the derivative, we would get negative 6y plus 6. And if we set that equal to 0, we get y equals 1. All we have to do now is find x. Well, to get x, remember, x squared is equal to the 16 minus y squared. So x would become, if y is 1, x becomes plus or minus root 15. So now we have two more possibilities. We have the square root of 15, 1, and we have negative square root of 15, 1. So we have two more possibilities for us. And if you recall from yesterday, so we got the critical numbers, we have the edges. Now we need to look at the corners. Now you might be thinking, corners of a circle? How does a circle have corners? Well, the easiest way to explain this, and I'll show why this works in another video, the reason why this works is if we think of the circle, x squared plus y squared equals 16. That's our circle here. It has a radius of 4 right here, and we want to find out where the corners are. Well, if we were to take a look at x squared equals 16 minus y squared, we take the square root of that, we would get plus or minus the square root of 16 minus y squared. Notice, this is going to give me the top half and the bottom half of a circle. So you might be asking, well, what are the corners? Well, the corners are where, well, are those endpoints. It's the endpoints for each semicircle, the top half and the bottom half, which occurs where? Well, at x equals negative 4 and y equals positive 4. But also I can do the same thing for this. I can say y would equal plus or minus the square root of 16 minus x squared. And then I can get on the other one, I think I switched my axes around here, positive 4 and negative 4. So the corners are at these points right here. And again, in another video I'll explain that in a little bit more detail. So the corners are going to be 4, 0, negative 4, 0, 0, 4, and 0, negative 4. Right there. And again, and that's only because if we were to graph half of a circle, the function's not differentiable at those 2 points right there because those are kind of endpoints. So we consider those the corners of our circle. All we have to do now is use our candidates test. All right, so let's take a look here. So we have all of these points we have to check. So let's see here. I'm going to zoom in quite a bit. So to do the candidates test, we're going to take a look at each point and the value at each point. So remember, our first one was 0, 3. I'm going to zoom in here. 0, 3. Then we had square root of 15, 1. Negative square root of 15, 1. Then we have our new points, 4, 0. Negative 4, 0. Keep going. X, Y. F of x, y. We have 0, 4, and we have 0, negative 4. And all I have to do is I'm going to plug all of these points into our function up top. And if we plug it into our function, if we plug in 0, 3, we would get 9. Root 15, 1, we get 35. Negative root 15, 1, we get 35. Plug in 4, 0, 32. Negative 4, 0 is 32. 0, 4 is 8. And 0, negative 4 is negative 40. So where's our absolute max? Well, the absolute maximum is going to be the highest value. There's actually 2 of them. There's our absolute max. It's going to be plus or minus the square root of 15, 1. And where's the absolute minimum going to be? At 0, negative 4, negative 40. Right there. And there we go. All right. I probably should write the point here, up here top as well. So that'd be at 35, which would be my maximum value. All right, I hope you enjoyed the video. And like I said, in my next video, I'm going to show why, more mathematically, why we consider those endpoints of the circle, those corners. Hope you guys enjoyed the video. See you soon. Bye.